Welcome back for another episode where we look at rebuilding the HANA OpenSAP Cloud 2020 project and updating it for the latest in HANA development and cloud application programming model development. So if you've been following along in the previous episodes, or maybe you've fallen behind thanks to the summer vacation season, that's okay. I'll do a quick recap of where we are so far. We have built our base project, and we've done most of our data modeling, certainly all the data modeling local to our application. We spent several weeks or several episodes looking at how to build reusable parts of our data model, how to build the master data parts, how to build the transactional tables, the views, and the various interaction parts. The last episode, we looked at a very hot topic, which is how to do cross-schema access to pull a non-HDI container schema into our application, and not just how to build it into the HANA database layers with the user-provided service and the grants and the synonyms, but then we also saw how to further pull that into our cloud application programming model data model through mix-ins, apply associations on top of those schema tables, and we even did a bit of pretty advanced authorization setup where we used a structured privilege check in order to be able to apply row-based authentication to our security as well. And so that last episode was really key. If you haven't watched it, episode number 5, I do encourage you to go back and have a look at that when you have a chance, because there's a lot of really deep, really important topics in there. Now, for today's episode, we will pick up where we left off, and we really want to accomplish two things. First of all, as I've been working on this video series, we've had some updates to some core libraries released, and I want to walk you through the process of updating our project mid-development for a major new version of the cloud application programming model, since version 4 came out just over the last couple of weeks. And also then that won't take too long. There aren't a whole lot of adjustments we have to do, but I think it's good to show you the process of what it's like to update a major new version of one of the underlying components like that. But then the main focus of today's episode will be to continue that theme of cross database access. But in today's portion, we want to build a second HDI container, or really add a second part of our data model to our main application, which in turn will create a second HDI container instance in the database, and then how we can access that from within our application as well. Maybe you want to segregate portions of your data model and be able to access them from within a single application. That's really going to be the main focus of today's episode. All right, as I described, let's start off here by doing some upgrades to our project. So first of all, let's see what all has been released just in the last couple of weeks. And one of the first things that was upgraded was the hdbext library, was just updated 8 days ago. And what this did is basically was an update, if we look here, to pull in the latest version of the hana-client to move to the HANA SPS 05 version of the hana-client, which included a couple of critical fixes. Particularly, I know some people on Mac were having problems with the hana-client, which then cascaded down to all the things that use the hana-client, like the hana-CLI tool. So this update came out, and it does include those fixes. So as I said, this then impacted hdbext, the little wrapper that I've created, the SAP hdbext Promisfied, which exposes these modules with promise wrappers around them, and the HANA CLI tool. I recently updated that as well to pull in all these new dependencies. So one thing that we're going to want to do is update our environment in the Business Application Studio to pull in the latest version of the HANA CLI as well. So what we can do there is, once again, we can just use npm, and we can just do reinstall it. Just do it npm install global HANA CLI. Although let's check this again. Let's make sure my npm config doesn't have the wrong metrics. Yeah, it looks like the registry is now pointing to registry.npmjs.org. So it looks like that's been updated in the Business Application Studio as well now. So I just wanted to double check that it happened. So now let's also do a HANA CLI version. There we are, and we can see that we are running version the 2020 July patch 3 version, and we had seen over here that the 2020 August patch 2 version is the latest that's available. So let's go ahead and update this, and like I said, in order to update it, we can just redo the installation. So npm install globally HANA CLI, and this will take a second to run. And there we are, all done. Now we can redo our HANA CLI version just to check and make sure it was updated. Yes, now we have the August patch 2. And inside here in the individual version, internal dependency versions, we can see that hdbext was updated to version 7, and now it's running on hana-client, the SPS 05 patch level 105 version of the hana-client, which we know from other sources fixes some problems, as I said, in the Mac environment. It didn't directly impact us here because we were running in the Business Application Studio, which is running on Linux in the shell. But I know from some issues that had been opened on GitHub that was an issue. There was a problem there, and that has been fixed now. So we see how easy it is to update the HANA CLI command line tool. By the same token, there was also a major new version of the Cloud Application Programming model released. The Cloud Application Programming version 4 is released. You can read about all the great new things in the Node.js runtime, some of the important changes, a few minor incompatibilities here, but mostly new functionality, new capabilities, which we like as developers, right? Read about it all here on cap.cloud.sap.com, but we want to go ahead and switch our project over to use this new version. So let's now go back over and see the process to do that. Okay, so the process to update the Cloud Application Programming model isn't wildly different. We're going to use npm to do that as well. Remember, we have our package.json file, and that's where our versions are all referenced here. So what we're going to want to do is first make an edit to the package.json. So I want to change the version 3 of CDS to 4.1. And I also want to go ahead and change the version of the HANA client here. Let's go ahead and change that to 2.5. And this is wildcarded here, so it'll pull the latest patch level. But that should get us to the versions that we need. I'm just double checking against my already completed project to make sure that all looks good. Now the other thing we're going to want to do here is you've got this package lock.json. And that's generated automatically when you do an npm install, and it's going to record the versions that were actually installed when you did the npm install. And what I want to do here is I want to go ahead and delete that package.lock.json, so it won't run against that, but instead we'll go back to npm and pull the latest patch levels available according to the new major versions that we've specified here. So now that I've saved that, let's do the same sort of thing. Let's do a cds-v, and we can see, yes, we are running the 3.34.3 version, and it's coming from inside of our project. So let's go ahead, now that we've deleted the package lock.json, I have updated the package.json. Let's just do, from the root of the project, let's just do an npm install. And this will take a moment as well, since we have major new packages there. Okay, so that pulled in. And of course we could go look in the node modules, but let's just do a cds-v again. And what we see here is we can no longer run the commands directly from CDS, the CDS just the CDS package. We now run the commands via the CDS development kit. So what we need to do, as it says here, is do an npm install globally SAP CDS DK or development kit. And this change to take all the commands and move them over to the CDS development kit, that was part of one of the major changes with the update to the 4.x version that just happened to the Cloud Application Programming Model. Now I should be able to do CDS version. There we are. And what we see is now we are running version 4.1.7. And that matches up to what we can see here if we come over to npm once again, SAP CDS, and we can see, yes, the latest available is 4.1.7, and that was just updated 2 days ago. Okay. Now, obviously, we want to do some checks. This is a major version change. We want to make sure that that we didn't break anything, that we maybe weren't using a feature the way we were supposed to be using it, or something like that. So what I want to do is I want to do my CDS build. Oh, so I have my focus in the right spot to rebuild my project. And what we see here, CDS build is done. Let's have a look at what it output. It should be the same. Uses the new compiler by default. It picked up our project. Yes, it processed our DB folder, our service folder, but I already know that there's a little problem here because I've done this to the project already. Most everything still built correctly, and there were no new errors. But if you were to look at the log very closely, you might notice that something is missing now from the output of the CDS build. No longer have my CSV files. Notice that there's no CSV files in the output. And if I go to DB, source, and gen, and I look here at the produced output, no CSV files, and no HDB table data for loading of any of our files. Now this would seem to be, and I found this in the documentation, it is referenced in the documentation that your CSV files need to be in a folder called, I think you can call it CSV or you can call it data, and it needs to be, well, it doesn't say anything about that. It's strictly in the documentation, but it said all your CSV files need to be in that folder. And what it seems to be is it doesn't allow subfolders anymore for like we had done. So what we're going to need to do is rename our loads folder. Now I'm just going to call this CSV. But now what we're going to need to do, I think once again, what I don't think that's enough to pick it up. I want to test this because there has been a patch just 2 days ago. I want to see if it still works the same way. And yes, it looks like it still does. Yeah, it still doesn't like subfolders, and we put all our CSV files into subfolders. So now we're going to need to pull all of those out and put them in a flat structure at the root. Get rid of the subfolders. See if I can drag and drop these all at once. Yeah, I can. There. Now all of our master data CSV files are moved over. Let's do all of our conversions. 10 files. There we are. And now all of our commons. There we go. Everything is now in a flat folder structure called CSV. No more subfolders. And let's do our CDS build again. This time, hopefully. Yes, now we see it picked up our CSV files and it created HDB table files once again. So that all looks good. And based upon my earlier testing in my finished version of the project, I do believe that was the only change that I had to make. Let me just check one more spot here. I don't think... yeah, I think we're okay. So let's go ahead and I did the CDS build. So now let's go into our DB folder and do an npm start to redeploy this into the database. Everything was sent over to the HANA database, and that should be good now. And just to test things out, let's do a CDS serve, so we can check our OData services as well. We'll open that in a new tab, and just like we saw before, now we can see our addresses, we can see our business partners. That all looks good. So I'd say that's a pretty successful switch over to the newest version. The only other thing that I want to do, try the Fiori preview. All right, we'll go ahead and there we are. If you remember a couple weeks ago, when I tried to use the Fiori preview from the CDS serve, it was not working for me. That was a little bug in the CDS runtime, and I think there was I was reading some notes. There was an incompatibility with an update to SAP UI5, and that has now been fixed in the latest version of the Cloud Application Programming Model, the 4.x version that just came out. So you can see here now that we've switched over to that newer version, our Fiori UI is working. Our Fiori UI preview is working once again. Because I don't have UI annotations yet, that's why I'm having to select my my columns. Later we'll add some UI annotations into the model itself, and then we can define which columns will appear here. In fact, we have that on the product category value help. I think I added those annotations already. Let's see. No, perhaps not. We'll we'll come back to that topic later. But the main thing that I wanted to check here is that yes, my annotations are working, so we're in good shape there. All right, now that we have everything updated, tested, working again, we're ready to continue on with our main task for this week, which is that we want to add another database module to our application and to our CDS model as well. So what we want to do here is we can, first of all, we can use the hana-cli. And there's a command here that will help us out a little bit here called create module. So let's go ahead and say hana-cli. Oh, let's make sure we're in the root. Yeah. So hana-cli, create module. And this is going to be for HANA Cloud. Oh, that's not what I wanted to do there. Pardon me. Let's see here. CLI, help, create module. CLI, module -h. There we are. Ah, I needed to supply a folder, otherwise it defaults to DB, because that's what I wanted to add on here. I thought it would ask me, but that's okay. We want the folder name to be, we actually want to create a second one here. We already have a DB folder. We want to create a second one called user.hdb. So let's go ahead. Yes, this is for HANA Cloud. So you see what it's created here is another folder called user.hdb. And it's already put like the package.json, the build script, the source with an HDI config already for us to go there. So it just kind of bootstraps things and makes it a little simpler for us. Just like we did in our other module, we can go into user.db and we'll do an npm install, so that can add the pull down the HDI deployer. Now the other thing that we want to do here is we want to go ahead and create its own separate schema in Cloud Application Programming Model. So I'll go ahead and create a new file here called schema.cds, just like we had in the root of our DB module. But in this one, I'm just gonna cut and paste this. We don't need to go through all the details here. It's not all that dissimilar to what we modeled before. We want to keep it pretty simple. We want a separate user entity. We're just going to have a GUID for the key, and then we're going to store our first name, last name, and email. And then we'll go ahead and annotate that with a title, description. We'll put the format validation via the assert format on the email address. But just enough so that we can see the interaction pattern, because we're going to create this, and it's going to be in its own HDI container, but then we want to see how to access it from our other main HDI container, the DB. So we'll just go ahead and save that. Now, the other part that we need to do here, now that we have two database modules, we need to tell CDS, the Cloud Application Programming Model, about that. So we'll go to the package.json in the root of our project, and you see here in the build task, we tell it, that we have the source DB folder, and then it's for HANA, and then it should use these models. But what we want to do now is we want to extend this. Let me just pull up my example here so I get it all right. We want to add another build option for user.db that's also HANA, and the model is going to be for user.db. And now I'll save this. Now when I go to the root, let's go back one, there we are, and when I do a CDS build after making this change, you'll see that now it's, and it went very fast, we'll have to scroll back up to see all that. Now it's going to build the DB module for HANA and for DB SRV. It's going to build the user DB for HANA, and we have the SRV folder that's a node for Cloud Foundry runtime. And if we see here, should see this is all our original DB source. If we scroll down, now in addition to we still have the server, we have user DB, and it's going into the SRC folder, and we got a gen, and it created the HDB table for us. And that's really all we need out of this part of our project. Now, before we build our new module and deploy it into the HANA database, there's a couple other little things we should probably take care of. Now, if you remember our mta.yaml, it isn't used anymore in our development process, at least until the end when we're ready to build the whole application. But still, we should keep it up to date as we go. So I think it makes sense here where, we added a new module. We want to go ahead and make sure that it's referenced here in our mta.yaml as well. So let's just come here and SAP Cloud user DB. Just took the 2020 out of here to make it different. So that adds the other module reference, and then we need to add the resource reference as well. So let's go ahead and grab that. And we'll just do the same thing. We'll take the 2020 out of there. There we are. Now we got a good mta.yaml. But as I said, when we do the build from the Business Application Studio, it doesn't use the mta.yaml anymore to allocate the resources as we used to do in the SAP Web IDE, for instance. We're going to want to create that container resource for our development purposes here manually from the command line. So let's go ahead and do that now. So I want to go into my user DB folder, but I wanted to, let's just remind ourselves as what we have out there already. I'll just do a CF services. Oh, it wants me to log in again. There we are, and I want to work in my trial. There we are. Now, if I do CF services again, we will see, yes, I have my HANA OpenSAP Cloud DB. That is the HDI container that we created previously. You can ignore some of this other stuff. That's something else I was working on for a different project, but this is the main thing that we've built so far. We want to create another one for our second HDI container, and we want to name it HANA OpenSAP Cloud User DB. So once again, let's do a CF create service. This is a HANA. That's our plan, and that's our service, and then our plan is HDI shared, and then the name we want to create is HANA OpenSAP Cloud User DB. And it is off and creating, and if you remember from the previous episode when we created the first container, this takes a few seconds, and we can do the CF services to check the status on it. We see the create is in progress, so we'll be patient here for just a moment while we let that finish creating. And there we are. Create succeeded. So now it's good. And what we want to do, we want to do a CF create service key for HANA OpenSAP Cloud User DB. just call the default key. There we are. And now, just like we had done before when we did our DB module originally, I will use the hana-cli. And we will use the hana-cli service key command to create our default-env.json, but this time connecting us to our new user.hdb instance in the database. So hana-cli service key, and hana-opensap-cloud user.hdb, and the key was named default. Yes, please encrypt. Validate the certificate. Yes, please. And yes, we are doing this on Cloud Foundry. So it is now connecting to the database. We have just verified that our connection is good, and then the credentials were saved into the default-env.json for the user DB folder. And now at this point, we can go ahead and deploy this into the database. We can just do an npm start from the user DB folder, and this will connect to the HANA database, but now not our DB container, but a new separate container, and it has written just our user table, has an HDB table into the database. And if we go ahead and do a hana-cli open hdbext, and we'll open the Database Explorer in another tab. And what we will see once we finish loading is, I left some stuff from before. We still have our hana-opensap-cloud-2020 container, and it's got all of our existing content. Like we come here and we look at the tables. Yes, there's lots of tables there, but you will not find this this user table anywhere. Instead, we will create another connection in the Database Explorer of type HDI container. Let's go ahead and sort by my org. And there's the new one that we just created, hana-opensap-cloud user-DB. Let's connect with it. And now when we look at the tables in this container, we have just the user table. So inside our single application, we have isolated different database artifacts away from each other, because you might want to control different security on them, because you want to create like an API layer between them. Maybe we want a part of our application to only be able to read from this extra table. But now we have it created in these two separate pools, if you will, two separate schemas, two separate HDI container instances, so they are isolated from one another. They are in two different schemas. They have their own set of technical users. So we have achieved the level of isolation that we wanted, even within a single application, a single cloud application programming model application. But now what we need to do is allow them to talk to each other. So we need to now bridge between these two. It's a very similar process that what we used to access a foreign schema, but now instead of a foreign schema, we're going to access a foreign HDI container instance, and we're still going to create synonyms to be able to access this user data. Now the part that we don't need to do is we don't need to create a user provided service in order to perform the grants. Two HDI containers can simply connect to each other, and they'll have an inherent trust with each other, and we won't have to create users and roles and things like that to make this work. Now, before we actually connect up the two modules, there's actually a little bit more work that we want to do. And I went ahead, so you don't have to watch me do a lot of typing again, I went ahead and added these additional items to our user DB module. So while the schema hasn't changed, so the cloud application programming model, what we've built at that layer, we still just have the one entity that is annotated. I wanted to add some other things here. First of all, I added a calculation view. Now, there is no calculation view editor yet available in the Business Application Studio as of the recording of this video. It's something that SAP has said is planned for Q4 of this year in our roadmap statement. So take that as a roadmap statement. That could change. Something that SAP is working on now. I had to, when I created this, I mean, you can work in the raw XML actually if you want, and I've been known to make a few changes to a calculation view working in the raw XML, particularly when it's one that's relatively small like this one is. I'm basically just building a calculation view on top of the user entity and exposing the 4 columns. Nothing too fancy going on there. The only thing I am doing, I am applying analytic privileges to it as well in what would be the header settings of the calculation view normally, the properties. But it's probably not realistic to work in the XML for anything very complex. That's why I've been keeping my project structure compatible with the Web IDE. I was able to actually go back over to the Web IDE, clone my project from Git, and then build this using the graphical calculation view editor. I'll show you that in a later exercise. There's actually something that we're going to want to do later where we build a calculation view and then pull it into the cloud application programming model layer. For now, I just want to demonstrate the different things that we can pull across in a cross HDI container. So I didn't go through the whole process to show you how I created this, how I went back over to the Web IDE, but I will in a later episode. In addition to the calculation view, I also have a stored procedure, which is just going to populate some initial test data, 10 records at a time, into the database. Just lets us bootstrap a little example data. I wanted to demonstrate a different way of doing this than what we were doing with the DB folder, which was putting the data in a CSV file and then loading that. Here, instead of loading the data, I'm generating it dynamically with a stored procedure. What else did we add? We added some roles so that we can set up the security. Well, first of all, because we have a calculation view with an analytic privilege, we had to also configure the analytic privilege itself and populate that into the database. And then we're going to need some roles as well that are going to allow us to grant access to our other container. And we just went ahead and created those roles as part of the HDI objects with an HDB role, unlike when we did the cross schema access where we had to go to the SQL console and create a role that could then be granted via the user provided service. Here we can just create the roles that we want to use to grant access as another artifact in the HDI container, and we'll see here in a minute how we can use that role then in a grantor file in our target database container that we wanted to share this with as well. So that's the majority of what I did here. Well, in between the video pauses, I did go ahead and build this into the database. You can see it was successful. I want to make sure I didn't make any typos before I started recording again. You can see my 8 new files deployed into the database. It has created the roles. It has created the calculation view and deployed it all into the database. Okay, so if we go back over to the Database Explorer, actually we don't need all these other windows now. If we now refresh here in our user.hdb instance, I don't think our tables will have changed, but now we do have, I did create a synonym to dummy that we needed in our stored procedure. Here we will see our stored procedure, init test users. If we want to go ahead and run this, we can just go ahead and generate call statement with UI. And there we are. It's ready to run. How many do we want to create? I don't know, let's create 15 users. We don't want a ton, but a few to play around with. And we'll go ahead and execute that, and it has executed. That's good. And if we want to verify that, now we go look at the data in the table. Data. Yep, we do have our 15 records. And if you're interested, I'm generating GUIDs here, but I'm doing it at the database level because we aren't passing through the cloud application programming model, so we don't get the automatic generation of the ID like we would if we were calling in through the service layer. So from the database layer, if we were to look at, well, let me go back over to the procedure. See, I'm just using a built-in function called SYSUUID. So when you do a select SYSUUID from dummy, it will call that function and generate a unique GUID for you. The rest of them I hard-coded because the rest of the data isn't all that interesting. Yeah, I could have gotten fancy and done some dynamic generation of different email addresses or something like that, but this was good enough for my testing purposes. And while I'm in here, why don't we check on the calculation view as well? So we come here to column views. We see that, yes, we have our user details. And we'll go ahead and let's just do an open data on it. Let's get our data preview. And if we want, we can just look at the raw data, and we're able to see the data from the calculation view level as well. And this proves that all of our security setup is good because we added an analytic privilege to this, and if we hadn't extended the security on our technical users, like we did in the previous episode, with a default access role, then we wouldn't be able to query this calculation view. We would have gotten a not authorized at this level. But since I showed that in the previous episode, I did not go into that in detail. It's all there in the source code if you want to have a look at it. But this proves that it's all good and working. All right, now we're at the point where we're ready to put all the pieces together and connect up these two HDI containers. In order to do that, we're first going to need the connectivity information from the default-env.json, right? So what we have here in our VICAP services, we've got this HANA entry, right? And inside there, we've got an entry for our connection. This is our user DB one. What we want to do is we want to go over and we want to add that to the default-env.json of the DB folder so that we'll actually have two HANA connections in the same environment. So we don't want to call that the same name though. We'll go ahead and give that correct name. That's good. We'll save that. And now the other thing that we want to do is we're going to have to, now that we have two containers, we need to add another environment variable here that lists the default name. Actually, we should go ahead and update there so that it knows when we're doing a deploy, we have to tell it which target container to use, which one will be our default container. And that's the original one that we created. We only want to use this other one, the, oh, and I didn't get that name right. This is user DB, isn't it? User-DB. We only want to use this one when we want to connect via synonyms to the second HDI container. So this is how we declare which one is our primary connection. And when we did the service replacements the other day, we went ahead and we put in a service replacement for the second the second container connection. Even though it didn't exist yet, it was okay, as the service replacement isn't actually used until we reference it in an hdbegrants or an hdb synonym. So it didn't hurt to have it in there already and pointing to something that didn't exist, but now we want to go ahead and use it. Remember, this is so we don't end up hard coding the service name in any of our development files, that we can use an alias name, HDI user service, that will be cross-referenced to hana-opensap-cloud userdb. So let's go ahead and save that. Now we can go to the config folder. Remember, this is where we do our configuration that will be processed before our actual source file and all the artifacts are created. And just like we had an hdbegrants for sFlight to grant roles from the foreign schema to our technical users, we can do the same thing with another HDI container. So here I will create something called user.hdbgrants. And let's go ahead and grab this. And what we see here is now we're saying use the connection called HDI user service, which cross-references to an HDI service. We don't need a user-provided service because we can directly connect with a trusted relationship here between our two HDI container instances. And it will say, please use the technical users of the other HDI container to grant this user role that we defined down here in the other container. So please grant the user role and the user owner role to our corresponding technical users, our object owner, application user of this DB container. And this will give our technical users of the DB module access to the user DB module. Now, while we're in this config folder, we're going to need another file here. So we want to create synonyms as well. So we want to create a file named user.hdb synonym config. And what this is going to tell it is we're going to create some synonyms, and we need to know which grantor to use to grant authorization to those synonyms. So once again, we're going to use the other HDI container, the user service container, to grant access to these foreign objects, the table itself, the entity created by CDS, and our calculation view. We'll save that. And now we can come here to our src folder, and we'll come to synonyms. Let's go ahead and create another synonym file. And what do we want to call this? We want to call this user HDB synonym. And this is going to look very similar to our synonym config, except we won't have the grantor in here. See, that's the only difference between the two, but you need both of them to work together in order for this to all work out. All right, so now from our user DB folder, let's do an npm start to deploy this new, oh, I'm sorry, not from the user DB folder. See, there was nothing for it to do. We want to go back to our regular DB folder, and we want to do an npm start from here to deploy these new synonyms into our original HDI container. Give that a second to finish, make sure I didn't mess anything up. No, it looks good. And what we will see here is now it went to our main HDI container, still sees the sFlights, hdbegrants, sees a second grant, user hdbegrants, but this is of type HDI instead of type SQL. So the HDI deployer knew to handle it differently and knew to use the other HDI container instance and its connectivity options to perform a grant to our target container, the DB container. And then that's what allowed us to be able to create these two new synonyms. And once again, if we go back over to the Database Explorer, but now instead of working in the user DB connection, we go back to the original, just the plain DB instance, which this has all of our tables, just to show you here. Yes, it has all the tables, but now we've got extra synonyms. In addition to the synonyms that allow us to access S-Flight, now we have a synonym that allows us to look at our other HDI container, the user details entity. So let's just make sure that the access works here. Yes, it worked. I was able to read the table. And let's make sure that the access via our calculation view also works. Yes, it does. So we're able to access via our calculation view also, but via synonym inside our source container. Now, in order to save a little time, I've done a few things off screen once again. I have brought this entity into the CDS model of my DB folder, but now I'm using the @SAP the @CDS persistence exist once again to create this sort of proxy entity that points to the synonym, which then further redirects us to the other HDI container, which was generated from a Cloud Application Programming Model entity as well. But we need to repeat the definition here. That points to the same names as the underlying database table, since we're coming in via a synonym at this point. I've of course added that to the main schema CDS, and I've actually added it to the service layer as well. And what will happen is the entity will be served out of the single SRV module, the service layer. The service layer only has connectivity to the DB HDI container and has no connectivity to the user DB. It doesn't need it because we'll do all of our access to this particular entity via the synonym and the connectivity that we've made behind the scenes within the database between these two containers. And the service layer has no idea that actually behind the scenes that two HDI containers are involved in this process. So now in order for this to work, let's go back to the root and let's do a CDS build. And now we can go into our DB folder and we'll do an npm start. That sent our one new file into the database, which is really just the master data service HDB view. Because the entities that you add to add to the service layer automatically create a view. And in order to test this, let's just do a CDS serve. And now we see we have our user entity exposed through the single service entry point. Oh, and it does not like the, I had ran into this before. It does not like the way the generated GUIDs are coming from the HANA database. It says they should be in a different format when they are EDM GUID type. And actually, I think I have a fix for that, but it was commented out here. If I change the OData type via annotation there. Oh, and let's rebuild this. CDS build. And now let's run that again. CDS serve. Now if we look at the user data, there, that fixed the problem. Basically what we're doing there is CDS was performing some additional validation to say, well, if this is a GUID, it should have the dashes in certain places. Generating the GUIDs from within the database level via the stored procedure, as we did, actually made the cloud application programming model think that those weren't valid. We were able to override that by adding an annotation to say the OData type is not EDM GUID, but treated as EDM string. And that allows that's why we passed the validation on the second time there. And that brings us to the end of another fun-filled episode. I hope you have enjoyed this deep dive look once again into cross-container access. This is also a fairly realistic scenario. Here we kept two containers within the same project. But you can imagine this could also be used to access an HDI container from a completely different project. And the technical process would be the same to be able to grant that access